Separating funnel. To do this experiment, we require a separating funnel, stand with a clamp, mixture of oil and water, filter funnel, and beakers. Take a filter funnel and place it on the mouth of the separating funnel, which is clamped to a stand. Pour the mixture of oil and water into the separating funnel through the filter funnel. Oil and water will appear as separate layers. Remove the filter funnel from the separating funnel and close the separating funnel using a lid. Take the separating funnel from the stand. Invert the funnel and shake it gently and slowly open the stopcock of the funnel to release the pressure inside the funnel. Place the separating funnel in the stand and allow the two liquids to separate completely. Oil forms the top layer and water forms the bottom layer. Take a beaker and place it below the separating funnel. Open the stopcock of the separating funnel and pour out the lower layer of water carefully onto the beaker. Close the stopcock as the oil reaches the stopcock. Take another beaker and place it below the separating funnel. Open the stopcock and now collect oil from the separating funnel. The immiscible liquids separate out in layers depending on their densities. The denser liquid will fall to the bottom, forming the lower layer, and the lighter liquid forms the top layer. Water is denser than oil. Simple distillation. We require a mixture of acetone and distilled water, stand with clamp, heating mantle, and porcelain chips. Take a mixture of acetone and distilled water and pour it into a 250 ml RB flask or distillation flask. Clamp the RB flask to a stand and place it in a heating mantle. Take some porcelain chips using a spatula and put it in the RB flask to avoid bumping while boiling. Connect a distilling head to the RB flask and a thermometer adapter to the distilling head. Insert a thermometer through the thermometer adapter. Connect a water condenser to the outlet of the distilling head. Connect a vacuum adapter to the water condenser. Connect a 100 ml RB flask or receiver flask to the vacuum adapter. Take an ice bath and place the RB flask in the ice bath. Connect a rubber tube between the tap and the inlet of the condenser to allow the cold water to enter. Connect another rubber tube to the outlet of the condenser to pour the hot water from the condenser to the sink. Open the tap so that water flows through the tube and fills the condenser and then comes out through the outlet. Set the temperature of the heating mantle to 56 degrees and heat the mixture to boil. At 56 degrees, acetone vaporizes and the vapors pass through the condenser and condensation occurs. The acetone is collected in the receiver flask in a liquid form. Water is left behind in the distillation flask. Simple distillation is used for the separation of a mixture containing two miscible liquids that boil without decomposition and have sufficient difference in their boiling points. Acetone boils at 56 degrees and water boils at 100 degrees. Fractional distillation. We require a mixture of methanol and ethanol, stand with a clamp, heating mantle, and porcelain chips. Take a mixture of methanol and ethanol and pour it into a 250 ml RB flask or distillation flask. Clamp the RB flask to a stand and place it in a heating mantle. Take some porcelain chips using a spatula and put it into the RB flask to avoid bumping while boiling. Connect a fractionating column to the RB flask. Connect a distilling head to the fractionating column and a thermometer adapter to the distilling head. Insert a thermometer through the thermometer adapter. Connect a water condenser to the outlet of the distilling head. Connect a vacuum adapter to the water condenser. Connect a 100 ml RB flask or receiver flask to the vacuum adapter. Take an ice bath and place the RB flask in the ice bath. Connect a rubber tube between the tap and the inlet of the condenser to allow cold water to enter. Connect another rubber tube to the outlet of the condenser to pour the hot water from the condenser to the sink. Open the tap so water flows through the tube and fills the condenser and then comes out through the outlet. Set the temperature of the heating mantle to 65 degrees and heat the mixture to boil. At 65 degrees, methanol vaporizes and the vapors first rise through the fractionating column and pass through the condenser. Condensation occurs and methanol is collected in the receiver flask in the liquid form. Remove the RB flask containing methanol and connect a new RB flask to the vacuum adapter. Again, set the temperature of the heating mantle to 78 degrees and heat the contents of the RB flask. At 78 degrees, ethanol vaporizes and the vapors rise through the fractionating column and pass through the condenser, and condensation takes place and ethanol gets collected in the receiver flask in a liquid form. Fractional distillation is used for the separation of two or more miscible liquids for which the difference in boiling point is less than 25 K. Centrifugation. We require milk, distilled water, centrifuge tubes, centrifuge machine. Take a centrifuge and fill 3/4 of it with milk. Place the centrifuge tube in one of the holes of the rotor of the centrifuge tube. Take another centrifuge tube and fill 3/4 of it with distilled water. Place it opposite to the first centrifuge tube to balance the centrifuge machine. Then, close the centrifuge machine and centrifuge the milk for 2 minutes and stop the machine. Take the centrifuge tube containing milk from the machine and observe the changes. The fat rises to the top, resulting in a cream layer at the top, and skim milk, that is plasma phase of milk, at the bottom. The denser particles are forced to the bottom and the lighter particles stay at the top when spun rapidly. Chromatography. We require a mixture of red and blue inks, distilled water, isopropyl alcohol, Whatman filter paper strip that is 20 by 2 centimeters, capillary tube. Take a Whatman filter paper strip 20 by 2 centimeters. Draw a line with a pencil above 4 centimeters from one end. Draw another line lengthwise from the center of the paper and name the point at which two lines intersect as P. Take a capillary tube. Dip it into the beaker containing a mixture of red and blue ink and take the mixture using the capillary tube. Put a drop of the mixture of red and blue inks at the point P. Allow it to dry in open air. Again, take mixture of red and blue ink using the capillary tube. Put another drop on the same spot and dry it again so that spot is rich in mixture. Take 5 ml of distilled water in a measuring cylinder and pour it into a chromatographic chamber. Then take 5 ml of isopropyl alcohol in a measuring cylinder. Pour it into the chromatographic chamber containing distilled water. Mix the contents of the chromatographic chamber using a glass rod. This mixture is used as the solvent. Take the filter paper and suspend the filter paper vertically in the chromatographic chamber containing solvents in such a way that the pencil line remains about 2 cm above the solvent level. Close the chamber and keep it undisturbed for some time. Notice the rise in solvent along with the mixture of red and blue ink. When the solvent has risen about 15 cm, you will notice 2 different spots of blue and red colors on the filter paper. Take the filter paper out of the chamber and mark the distance that the solvent has raised on the paper with a pencil. This is called the solvent front. Dry the paper and put pencil marks in the center of the blue and red spots. Measure the distance of the solvent front from the original line and the distance of the 2 spots from the original line. Calculate the RF values of the blue and red inks by using the formula.